Hello, my name is Lusen, and today I will be explaining how to do problem 25 from the 2022 MCA. The problem reads, a cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? Our answer choices are A, 2/9, B, 19/80, C, 20/81, D, 1/4, and E, 7/27. So right off the bat, we can start off by labeling the leaves A, B, C, and D. We can also establish that P of n is the probability that the cricket is on leaf A after n hops. And we can go ahead and draw a chart. So on the left-hand side, we have n, and on the right-hand side, we have P of n. N is the number of hops, and P of n is just the probability that the cricket is back on leaf A after the n amount of hops. So when n equals to 1, P of n is equal to 0. That is because when n is equal to 1, the cricket must jump to one of the other 3. So it's impossible that the cricket would immediately return to leaf A on 1 hop. When n equals 2, however, the probability changes to 1/3. That is because from any of the other 3 leaves, B, C, and D, there's always a probability of 1/3 that the cricket automatically jumps back to leaf A. So let's say the cricket were to jump to B in 1 hop, there's a probability of 1/3 that it jumps back to A in the next hop. When n equals 3, it gets interesting because if the cricket were to jump back to A in the second hop, the probability that it jumps back to A on the 3rd hop is 0 because it's already on A. But however, if the cricket never jumped back to A and it went to some other leaf, such as C, then there would be a chance that it could jump back to A on the next hop. So what we are looking for is the probability that the cricket doesn't land on A in 2 hops. So at the end of 2 hops, the cricket cannot be back on A. So we do 1 minus the probability that the cricket is on A after 2 hops, and we get 2/3. But we're not done yet because we have to multiply by 1/3, because again, that is the probability that from any of the other 3 leaves that it jumps back to A. And so 2/3 times 1/3 is 2/9. And we can put that here. And for 4, we can use the same idea as before. We don't want the cricket to jump back to A on the 3rd hop. We don't want that. What we want is the cricket to jump to some other leaf in the 3rd hop so it can jump back to A in the 4th hop. So again, we do 1 minus the probability that it does go on A after 3 hops. So that's 7/9. And then we have to multiply by 1/3. So our answer is 7/27, which is E. Thank you for watching this video.